Okay, hello everybody. So I just want to make another little video about the effect of the lack of gravity. We need to do a little thought experiment in order to understand what happens when there's no gravity. Now, the scientists will say that gravity reaches basically infinitely, reaches everywhere. But there's a little issue with that, in that if you're in the middle, if you're in between all of the galaxies, each one of them are pulling on you, or in other words, there's if there whatever gravity there is, all of the galaxies are pulling on you, their direction. So the net effect is a canceling out of gravity between if you're between galaxies. So we have to do this thought experiment because it's the exact opposite of if you were near a gravitational well. Whenever you're near a gravitational well, it contracts distance and slows down time virtually to a stop. So the time stops and distance is contracted to no distance. It's kind of like the same thing, except the opposite. If when you're going the speed of light with special relativity, distance contracts then too, but time goes at a faster and faster rate, so that time is almost basically virtually instantaneous or instant. So if you're going the speed of light, it takes no time to travel, no distance, and you're already there. Anyway, in general relativity, it's has nothing to do with speed. It has to do with the what they call acceleration. And there's really, if you have like two equal masses pulling against you and you're in the middle, like what they call the Lagrange point, you're not going anywhere. There's no acceleration, basically no acceleration, and the amount of gravity drops off exponentially, so that there it goes from a lot of gravity to basically almost no gravity for all intents and purposes. So what happens is that with no gravity, time is going to speed up very, 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 very fast. And distance is going to be expanded very, very, very much, which has the effect of not being as far. Because if you have the same measure of distance being very large, that means the distance isn't as far as what it appears to be to us if we project our measure of distance onto the rest of the universe, especially in our line of sight between galaxies. So I'm hearing more and more, you know, people agreeing with me on this, and uh, and they're finding out more and more things that confirm it. For example, they found out that the dark energy is associated with black holes, or the vacuum of space is associated with black holes, which they assume the vacuum of space is because of some kind of magical dark energy, photon or inflaton, that inflates the universe. But they think it's inflating black holes, which is really strange because black holes are, that's a place where nothing is inflated, everything contracts. But what's happening is that the black holes are increasing in size because of drawing in space time. They actually draw in and they grow with drawing in space time, regardless of whether there's any matter being drawn into the black hole. So, but they think that the black hole is inflating because of dark energy inflatons or something. But all it's doing is increasing in size because it's drawing in more space time. And another point that's a confirmation as well is I heard another scientist say that black holes keep you from seeing the light, not because of gravity, not because of gravity, but because of being redshift out of our range of detection. So it's the the light coming from black holes we can't see basically because the distance is too far away. So in other words, the distance is so far away in a black hole, the distance is actually farther than the farthest galaxy that we can see, that we can detect with the James Webb telescope that sees everything in infrared spectrum. So the only reason why the James Webb telescope can see those distant galaxies because it's detecting the light, or it's receiving the light and detecting the light in way into the infrared spectrum. And yet light from a black hole is even farther than that, so that it can't detect redshifted light from a black hole. So this is an amazing, amazing thing, which confirms what I've been thinking about anyways all along. It's really amazing. So basically, a lot of people are agreeing with what I'm saying. I mean, a lot of times you post stuff and people don't want to agree with you or anything, but I'm having a lot of people agree with it and then say, yeah, that's pretty interesting. And they're asking me about it, asking questions about it. One guy went back and forth with me a long time saying, yeah, but if you're looking straight through, expanded distance, is the light redshifted? I had to explain to him that the light that we see isn't straight through expanded distance. It's originating from a contracted distance, area of contracted distance. That's where the light is originating from. So it's as it moves out of the galaxy, it's going through places that are more and more expanded distance, which is causing the redshift. So all this expanded distance is what causes the redshift. Then when light comes into our galaxy, it's slightly blue shifted. I mean, slightly, I say, in comparison to the huge distance between us and distant galaxies, which is an interesting thing, is the light that they're seeing from the galaxies is from the innermost parts of the galaxies, and they're bigger than they're expected to be because they're closer than what they realize. They're something like 10 times larger than what they expected them to be. But then again, they're not even seeing the stars from the outer edges of the galaxy. They're seeing stars from the more gravitationally contracted distance in order to be able to see it. Because light is blue shifted going into galaxies, and we still can't see light from a black hole, which we're looking straight into the center of the galaxy. We still can't see light. Well, because it would be coming from a very contracted measure of distance, expanding, and then it's redshifted out of our range of detection. which is what the scientists were saying, which was, I thought, a lot more impressive than saying light can't escape because of the gravity that keeps it from escaping. They're saying the speed of light isn't enough acceleration for the light to leave a black hole, which doesn't make sense to me because, I mean, the entire distance all the way to the black hole is not a singularity to begin with. And then what is a singularity? If there is a singularity, we're not going to see it anyways because time goes too slow. But anything else going as you leave the center of the galaxy or the center of the gravitational well is going to be redshifted because it's going through expanded distances. Now, if it was light from us going to the black hole, the light would be blue shifted because it's going into the black hole. Light coming into the galaxy is blue shifted. Light going out is red shifted. So that's why we're seeing red shifted light from the center of the galaxies, distant galaxies, because of the great distance it has to travel through expanded distance, which means that the galaxies are a lot closer than what they appear to be. But anyways, thought that was very interesting. Hello, Iron Matt. Good afternoon. How do we really know the distances? Aren't they assuming a lot? Yeah. Well, they're projecting our measure of distance onto the rest of the universe. In other words, when they see what they call a superluminal velocity of plasma shooting out from the center of a galaxy, they measured it with our measure of distance. They measured it going 7 times the speed of light. But obviously, it's not going 7 times the speed of light because it can't go 7 times the speed of light. The problem is that they're projecting our contracted measure of distance onto that area, which is more expanded because the farther away you get from the center of a galaxy is more expanded it is. So it also means that the distances are greater than what they appear to be. So they need to use those kinds of things to calibrate our measures of distance so that they can get a better idea of how far the galaxies are away. And of course, if the galaxies are closer than what they think they are, the light is arriving faster, plus the fact that time runs at a faster rate where there's no gravity in our line of sight through the space where there's no gravity, time is running at a faster rate. So that's why we can see distant starlight in the first place, and we can see the redshifted light from distant galaxies, and we can't see the redshifted light from the center of a gravitational well, from the center of our universe, the Sagittarius A. We can't see light from there because it's redshifted out of our ability to detect. Not even the James Webb telescope can detect light from a black hole because of how redshifted it is coming out. But it can detect distant galaxies, which means the distant galaxy is closer to us than the center of our black hole, Sagittarius A. That's what it means. And I always thought a long time ago, I thought it'd be funny if all of a sudden light started coming from all these black holes everywhere. They would be surprised, and I would laugh if we started seeing light coming from a black hole, redshifted light coming from a black hole. That would be funny. But it's actually a greater distance to the center of our galaxy than it is to the farthest distant galaxy that we can hardly see with a James Webb that's redshifted out of our range of detection with a James Webb. because James Webb still can't detect light, redshifted or otherwise, coming from a black hole. So there you go. The distance is farther. Another fact that's true is that the circumference of the black hole, or let me start with the radius of a black hole is a greater distance than its circumference. So the distance around a black hole is smaller than the radius from the outside of a black hole to the center. The distance from the outside to the center is a greater distance than the distance around the black hole, which I always knew for a long time. But that's one of the curious things, and it's just falling together. The facts are accumulating, and it's the reason why we can see distant starlight within 6,000 years in the first place. So amazing things are happening. It reminds me of the song, the old Irish song that says, "Cheer up, you saints of God, there's nothing to worry about, nothing to make you feel afraid, nothing to make you doubt. Remember, Jesus never fails, so why not trust him and shout? You'll be sorry you worried at all tomorrow morning." It's a great day to be a creationist. God bless everybody. Take care. Plus, we have genetics backing up the 16 grandsons of Noah coming off the ark that everybody's descended from. So God bless everybody. Take care. And it's a great day to be a creationist.